Matlab provides a way to represent polynomial. Okay, if you recall, polynomial is a function of this form. This highest power is called the degree or the order of the polynomial, this highest power of n. Then these an's are called coefficients. Okay, for example, this is a polynomial of degree 5, this is a polynomial of degree 2, and a polynomial of degree 1. Okay, constant term is a polynomial of degree 0. Okay, Matlab, we represent polynomial by giving the coefficients in a vector. You have to give the zero coefficients also. For example, 8x plus 5 coefficients are 8 and 5. To represent that polynomial in Matlab, I give 8 and 5. Okay, in a vector. 2x squared minus 4x plus 10 has coefficients 2, negative 4 and 10, so I give them in a vector. 6x squared minus 150, here you can say the x coefficient is missing, x term is missing, that means x term is 0 here, that's why it's missing. So these zeros have to be given when you are representing a polynomial in Matlab. So its coefficients are 6, 0, the coefficient of x also included, and 150. Here if you look at here, you can see coefficient for x to the 4 and x to the 3 are missing. Terms for x for the 4 and x to the 3 are missing. Those means the coefficients are 0, and also constant term is missing, that is also 0. So the representation in Matlab is 5, 0, 0, 6, minus 7 and 0. Okay, you have to include the 0 ones also. It's important when you go to evaluate. Okay, so to evaluate a polynomial, we use this, we use polyval, and we pass the polynomial in vector form and x. Okay, for example, let's say I want to evaluate 2x squared plus 5. Okay, 2x squared plus 5, so the polynomial should do 2 coefficient of x squared and then 0 coefficient of x and 5. Okay, so this is the polynomial 205. I can use other letter here also. Okay, instead of p I use p for polynomial, and then polyval I give p, and if I, let's say, if I want to evaluate at 1, I get a 7, so that is the correct value. Okay, and if I want to evaluate at 100, I just say 100. Okay, also I can pass in a vector value for this x, then polynomial will be evaluated at each value. Okay, so for example, I can say x equals, let's evaluate the polynomial at 0, 1 and 2. Okay, now if I pass this p and x, it will be evaluated at each x. Okay, so at 0, if I evaluated this polynomial, it's 5, at 1 I get 7, at 2 I'll get 13. Okay, so when I evaluate the polynomial at 2, I get 13. Okay, So at 0 it's 5, at 1 it's 7, and at 3 it's 13. Okay. Now we can use this and graph a polynomial. Okay, for the polynomial, this one, calculate f9 and plot the polynomial between these two values. Okay, so first I will have to write my polynomial. I'll clear the screen first. So my polynomial, I use p. Okay, I can use any letter here as long as I can. So the first coefficient is 1, second coefficient is 12.1, third coefficient is plus 40. Okay, and second one is negative 12.1 plus 40.59. Next one is 17.01 and 71.95 and 35.88. Okay. Okay, so these are the coefficients. Okay, it don't have any missing ones, so I don't have to put zeros. So these are the coefficients for my polynomial. I can just simply do this in command line, poly, I keep poly, to evaluate it at 9, I simply say p and 9, Okay, for the third one I entered the wrong one. Let's look at this 17.15. Okay, I entered 1. Okay, let us correct that. So P is this 15. Let's try that. Okay. 40.59 negative 17.015. Okay, this third one is a negative. Again I missed the third one. Sorry. Okay, because there are many coefficients. I am comparing it with previous answer. Okay, so that's correct. Okay, so these are the coefficients. Sorry, I kept entering the wrong coefficient. So this is the polynomial. Value at 9, and now I have to plot this one. Okay, to plot I can use linspace option. Plot it between what? negative 1.5 and 6.7, no? Negative 1.5 and 6 1.6.7, no? Let's say use 600 points. Now I have to evaluate y for each of these, so I say y poly. I keep typing the code here, polyval, sorry. P and X, no? Okay, so this is the graph of the polynomial. Okay, if I want, I can do grid on, put labels and like that. If I want, I can do. Okay, so this is how you will draw a polynomial and how you evaluate a polynomial.